Of course it wouldn't be bad if we get points for every dot Pacman eats and it is also displayed, or what do you think? Let's get started. For this we create a new variable called score and a new method that takes over the update. We then increase the points in the move Pacman method for each dot he eats. But one by one, see for yourself how easy it is. Alright, it's time to bring some bling to our Pacman game. This section creates a neat and tidy UI element to keep track of the player's score. Because, let's be real, scoring points is half the fun. Here's how it works. First, we create a label object and give it a name, score label. Think of this as the game's little announcer, constantly updating the player's score. It's like Pacman's scoreboard, but cooler. This line sets what the label will display. We use string interpolation to show the current score value dynamically. So, every time you chomp a dot, this label will cheerfully tell you your updated score. Here, we decide where the label will appear on the screen. We use 10 for the x-coordinate, so the label is slightly padded from the left edge. For the y-coordinate, we calculate the bottom of the game grid by multiplying the number of rows, level grid. Get length 0, by tile size, and then add 10 pixels for padding. This ensures the label is neatly placed below the game board. Now we make sure our label looks as sharp as Pacman himself. Auto size equals true. This allows the label to automatically resize to fit its text. No awkward cropping here. This sets the font style to bold, using a classic and readable typeface, Arial. It's clean, bold, and screams, "Look at me." Finally, we add the label to the form's controls. This makes it part of the visible UI so it shows up right below the game grid, ready to track your score. Why it's awesome. This little piece of code is the unsung hero of your Pacman game. Without it, how would players know how many dots they've devoured? It's functional, it's stylish, and it's perfectly positioned to keep players glued to their score. And that's how we set up a simple yet effective UI element for tracking the score. Next time someone brags about their Pacman skills, they'll have the numbers to prove it, thanks to this nifty label. It looks pretty good, but it does not yet show the correct score. We also don't get any extra points when we eat dots. We can fix this with a small change in the move Pacman method. Alright, let's talk about how Pacman racks up those sweet points while munching his way through the maze. This section ensures the score goes up when Pacman does what he does best, eating dots. Here, we check the tile at Pacman's new position on the grid. Remember, new position is where Pacman is headed, so we're essentially asking, what's on this spot? Is it a dot? A ghost? Empty space? This single line is the detective of the game, it sniffs out what's about to happen. Now, we check if the tile contains a dot. Dots are represented by a character on our level grid. If the tile is a dot, then Pacman has just eaten it. Nom nom. Time to reward the player. Every dot Pacman eats is worth 10 points. So, whenever he lands on a dot tile, the score goes up by 10. It's a simple rule but oh so satisfying when you see those numbers climb. This is where the magic happens. After increasing the score, we update the score label on the screen to reflect the new total. This finds the first label in the form's controls. Since our score label was the first and only label added, this works perfectly. We use string interpolation to set the label's text to display the updated score. The player gets instant feedback, no delays. With this functionality in place, Pacman isn't just moving around aimlessly, he's playing for points, and the player knows it. That little dopamine hit from seeing the score go up? Priceless. But what is that? There seems to be no end. Even when all the dots are eaten, the game continues and nothing else happens, no message that it is finished or a jump to another level. This is of course very frustrating for the player in the end. Let's change this next with a small method. Alright, let's talk about the ultimate goal of Pacman, clearing the maze of all those delicious dots. This part of the Move Pacman method ensures the game knows when you've won and celebrates your victory. This line calls the dots remaining method to check if there are any dots left in the maze. Dots remaining is like Pacman's personal inspector, it scans the entire game board to see if there's a single dot still hanging around. Here means not, so the condition is true if no dots remain. In other words, Pacman's job is done. After congratulating the player, the game exits by calling application exit. This closes the application cleanly, bringing the game to a satisfying conclusion. The return statement ensures no further code in the Move Pacman method runs after the game ends. It's a clean and respectful exit, a proper bow after a victorious performance. Think of it like Pacman scanning the entire maze in super speed mode, checking every spot to see if it contains a dot. Each tile is represented as a char, and the loop looks at one tile at a time. If a tile contains a dot, the method immediately returns true. This means, yes, dots are still remaining in the maze. The loop stops as soon as it finds the first dot, it doesn't bother checking the rest of the grid. Efficient, right? This means the maze is completely clear, no dots remain, and Pacman's mission is accomplished. This combination owes the final confirmation that the player deserves to win. Why it's important. Dots remaining in the victory check ensures the game knows when it's over. It gives the player a sense of accomplishment and makes the game loop feel complete. Without it, you just keep playing endlessly, wondering if there's any point to it all. With this functionality, we've added the cherry on top of our Pacman game. It's not just about moving around or eating dots, it's about achieving victory and celebrating it. That's what makes a game satisfying and memorable. However, it is still possible to eat the ghost without harming yourself. Let's fix that next. To do this, we create another query above the dots remaining method that triggers a new game over method if Pacman's position overlaps with one of the ghost positions. See for yourself. Alright, buckle up, because we're about to cover one of the most thrilling parts of our game: what happens when Pacman and a ghost cross paths. This snippet is the heart stopper of the Move Pacman method, where Pacman either dodges danger or gets caught. Let's break it down. Here's where the game gets intense. Ghost Positions is a collection that tracks the current positions of all the ghosts in the maze. If Pacman's current position matches any ghost's position, it's game over. Think of this like a radar system. If it detects a ghost in Pacman's exact location, we're in trouble. Now, if a collision is detected, the game over method is called. This is the code equivalent of Pacman screaming in terror and the game saying, "Alright, that's it, time to end this round." Once a collision is detected and the game ends, there's no need to process the rest of the Move Pacman logic. Return ensures we stop right here and don't waste time updating tiles or checking anything else. It's like slamming on the brakes when a ghost pops out. So, to wrap it up, this snippet is all about keeping Pacman on his toes, or wheels, or whatever he has. It's the dramatic moment where a single step in the wrong direction could spell disaster. Without this, there's no challenge, no stakes, and no game. And trust me, when a ghost catches you, it's a mix of heartbreak and motivation to try again. Now it gets a little more difficult for Pacman. A collision with a ghost ends the game.